Today we are going to be talking about vertical and adjacent angles. Okay, before we can talk about vertical and adjacent angles, we first need to know how to name angles or how to label them. Okay, so if we are taking a look at this angle here, it's labeled by A, B, and C as points on these rays. Okay, and there are several ways that you can label these. Okay, so this is our symbol for angle. Okay, angle, and we can follow this angle here. This is the angle that we are labeling. You can see here that we can call it angle 5. Okay, we can call it angle B. Okay, we can also label it angle A, B, C, because if I follow this angle around, I hit A first, then B, then C. Notice B is the middle letter, okay? I can also label this one more thing, 4 different ways to label one angle, and that is going to be C, B, A. C, B, A. Notice B is still the middle letter in that label. Okay, so you can label it 5, you can label it angle B, you can label it A, B, C, or C, B, A. Okay, and let's take a look here on this one. Same thing. If we are looking at this, this is angle 12, angle Y. Okay, angle X, Y, Z. Again, in that order, okay? Which one you come across in order. X, then Y as the middle, then Z. And then you could also go the opposite direction, Z, Y, X. Those are the 4 ways you can name an angle, okay? You can try 2 and 4 on your own, but again, you are labeling this angle here. You are labeling this angle here. Okay? All right. Now let's talk about vertical and adjacent angles. Okay? Vertic uh, Vertical angles are directly across from one another through the vertex. The vertex is this very center point where all of the angles share, okay? They come together right there. So if we are talking vertical angles, they're directly across from each other through that vertex. See that? Okay, now if I went over here to 4, see there's a bend in my line. Okay, so that does not work. Vertical are directly across from each other. Okay, 2 and 5 directly across from each other. Okay, so my vertical angles, I have angles 3 and angle 6 are vertical. Angle 2 and angle 5 are vertical. Again, directly across from each other through the vertex. Okay, and then angles 1 and 4. Again, it cannot be 6 and 2, or 6 and 4, or 5 and 3. Those are curved lines. They have to be directly across from each other. Okay, which means you're going to get a straight line when you do that. Okay, now name all angles that are adjacent to angle 1. That just means next to. Okay, adjacent means next to. They share a line. Okay, so angle 1 shares a line with angle 2 and angle 6. Okay, angle 2 and angle 6 are adjacent to angle 1. Okay, let's try another one. 3 more pairs of vertical angles. So again, 8 and 5 directly across from each other. So my vertical angles are angles 8 and angles 5, angle 7 and angle 4, again, straight line, okay, and angle 3 and angle 6. And then my angles that are adjacent to angle 8 is right here, okay, so it shares with 7 and 3. It is next to angle 7 and angle 3. And I'll erase all my crazy lines so you can see those. Okay, angle 7 and angle 3, where those other two lines are, okay, are next to angle 8. All right, and you can try this one on your own. Okay, all right, now, sometimes it won't be that simple where they just have numbers there. They're going to make you solve. Okay, now you should know your vertical angles are equivalent. That means they are exactly the same. Okay, so let's come back up here. So if angle 4 is 68 degrees, that means angle 7 is also 68 degrees. Okay, so vertical angles are equivalent. They're exactly the same. Okay, if angle 3 here is 15, well then angle 6 is also then 15. Okay, so that means when we are solving for something like down here in number 9, that means 130 is equal to 3x minus 20 because this 3x minus 20 and 30 are vertical angles. Okay, so they're directly across from each other through that vertex, and they are equivalent. They're exactly equal. So we can write an equation that represents that. Okay, and you can then solve. So you are going to inverse operations, add 20 to both sides. Okay, that means you have 150 equals 3x. Then from here, inverse operations, 3x is 3 times x, okay, which means we are going to divide in order to solve. Okay, 150 divided by 3 is going to be 50 equals x. Okay, so that means x equals 50 degrees. Okay, x equals 50. Okay, let's try one more. So again, vertical angles, which means 75 and 5x are equal. So we can write an equation, 75 equals 5x. This is just a one-step equation. 5x is 5 times x, so we are going to divide by 5 on both sides. And 75 divided by 5 is 15. So x equals 15 for this one. Okay. Now 5x, remember, is equal to 75. So this angle here is 75 degrees. Okay. It's just x is 15. Okay. You can try those two on your own. All right. And one more type of problem here. Write and solve an equation to find the value of x. Okay, now this says the measure of angle ABC. So they tell you A, B, C, all of this together equals 128. Equals 128. Now, all of this in here is 80 and 4x. So that means 80 plus 4x together equal 128. Okay. From here, we just solve like a two-step equation. Subtract 80 from both sides, and you are left with 4x equals 48. Divide by 4 on both sides. X equals 12. So the value of x is 12. Okay. Let's do one more like that. Again, they tell you W, X, y, that means this entire thing here, is 170 degrees. So 170 equals 9x and 53 together, which means we are adding them. Okay, subtract 53 from both sides. I get 117 equals 9x. Divide by 9 on both sides. And 13 equals x. 13 equals x. Okay, and you can try 16 and 18 there on your own, but this is how we use vertical and adjacent angles to solve, okay? Remember, vertical angles, they're exactly equal, they're equivalent to one another, okay? And adjacent angles are directly next to one another.